So let's talk about this question. Firstly, you need to implement a log class, which has three functions inside it. One is the start, which takes a process ID. So this is an event, okay? And this method over here is something that's called a listener. So every time there is a start event on a process, this function will be called, okay, with its start time. So in fact, in our case, the start time will be calculated by us. We are just going to do a system.current time release. And similarly, there's an end time with a process ID. So this process has ended, this process has started. These are the two events that we have. And what else? We have something called a poll function. This poll actually looks at the earliest completed process and then prints that out. So that's the reason why this is a log. All it does is it just prints things out, but this is effectively an aggregator, and we'll see why. When you say the earliest completed process, okay, it will actually wait for the process which is the earliest process in this system. So I have three processes, process ID 1, 2, and 3, and they are starting, the start times are 12, 8, and 7. Okay, so this logger is going to be taking the very first process which has started and waiting for it to finish. Till it finishes, the poll method will block. Okay, that's important. The poll method needs to block, and till the process finishes, it's going to be just, returning null, possibly not printing anything. That is another thing. But when it finishes, when the end method on process ID 3 is called, and it's, say, let's set to 19, then the poll method should print process ID 3 started at 7 and ended at 19. Okay, that's what needs to happen. If you call poll again, then the second earliest process, like this is the second oldest process, which is process ID 2, which started at 8 and ended at 12, that will be printed out. And finally, if you call the poll method again, then I'm going to be printing out process ID 1 started at 12 and ended at 15. Okay, so these are the three functions you have. Two of them are just listeners, event listeners, and one of them is an actual function in which you need to output something. Okay, there is void over here, but because that is the reason why this is a log, so you will be printing to the output stream. Is this point clear, guys? Okay. So if you have any doubts, of course, you can keep posting them in the comments in the live stream chat. And let's think about how do we solve this first. So in a low-level design interview, by the way, this happens to be a question which was asked in a Google interview. So it's not going to be extremely difficult, but it's not going to be too easy either. When you come up with a solution over here, you'll probably see that there's a lot more you can do with the same question. Okay, that's one of the specialities of usually Google interview questions, that they have simple solutions, but you can always make them more complex with a little, tweaking around in the question. So, firstly, we are going to be defining something called a process. So this is the process class, and what does it have? It has an ID, it has a start and an end time. So I say string ID, and this is not going to change, so I'll just set it to final. And I also have a start time, which is not going to change. And then I have an end time, which is actually going to be sent to me. So this is going to be a long. Both of them are going to be long, basically. All right, and I can initialize these two in the constructor. Every time the process is created, when you call a start method, I'll be registering a process. Okay, so this is a string ID. And what else do I need? I need the start time. So the start time is going to be, in fact, I can just take the start time also as a parameter, final long start time. So there'll be a timer which is going to be giving me this. And the reason I'm actually taking start time as a parameter is because, later on when we'll be trying to test this function, it'll make life easier. We can do some dependency injection there. Okay, this dot id equal to id. Perfect. So we have a process now, and what we are going to try to do is we need some sort of a data structure which is going to be allowing this kind of thing, like being able to tell you what is the earliest event, and then checking if that event has ended. If it has ended, then we print it out to the log. Otherwise, we don't need to except hold these events in memory. Okay. So, okay, Satyendra Kumar has an interesting suggestion that start time can be system.current time millis. But the reason I'm not doing that is because I can actually pass this in, and later on through dependency injection, I can actually set a different kind of timer. So during tests, I don't need to depend on the system timer. I can actually define my own timer, which will be a mock, and that will work well. And we'll see how that works. But so I've defined the process, and now let's see how we can implement this LogClient. Interestingly, most interview places will not allow you to use your own IDE. So, all this fast typing that I'm doing is not going to be possible there. But the general idea is the same, of course. So I'll just call this logo implementation, and it extends, actually it implements the LogClient. And over here, I can just override these three methods of start, end, and poll. Okay. Now, let's think about what do we need to actually store processes in our logger, because till they have ended, we need to store them somewhere in memory, right? So one of the things we can do is to have a mapping between the ID of the process and its start and end times. Okay. Okay. There's actually multiple things we can do. Firstly, you can use a linked list. Okay, but that's not a great idea, because when you use a linked list, every time a person says start this event, you can add to the linked list quickly. But every time someone says end an event, you'll have to do a linear search on the list for the processes. So I'll just, in fact, I'll make the data structure. So list of processes. This is what our logger implementation is holding till they are completed, right? You need to hold this. So processes. And in a real interview, you don't need to prove all these things. You can just tell them that, hey, the list will not work. But in our case, I'm just trying to make it a little more clear. So I'm going to be taking this and setting that as an array list. Great. Now, when a person says start this process, what I need to do is I need to go to the processes and I say add this process. I'm sorry, I actually need to add a new process. So new process, and what do I need to pass here? The process ID and the start time. So over here, the interesting thing comes in. I need a timer. So private final timer. Now, this is weird. Like initially, in fact, thinking that into the future is not natural in a low-level design interview or any interview, because you are under so much pressure, you can't, plan everything out well. So I'll just keep this as system.current time millis. Okay. And okay, so adding a process is simple enough. When a process ends, we need to be able to somehow tell that the poll, the poll method needs to know that this process is, done. So I'll just get the process. Yes. And here we see the problem, of course. So when you want to get a process with a particular process ID, you can loop in the for loop for all processes, but that is going to be slow. That is going to be an order n operation, and in an interview, you're not not even in real life do you want to do order n operations when you can skip them. So one very natural thing about this is to just go for a map. A map of what? You have a key of process ID, and for that you need a process. So you just go for a string to process mapping. Okay. And no longer the array list, so I'll just go for a hash map. And over here, I don't just put the new process, I actually say that process ID needs to be put in. Okay, so now I can do a simple get process ID. I need to set this end time. So end time is private, so I'll just put a getter method over there. I'm sorry, I need a setter method. So this is not going to be true for all languages, but most of you program in Java, so it's fine. And over here I have system dot current time millis. If you're programming Golang or Python, you don't need to set any getter or setter methods usually. Okay, so you have poll, and this is the big method. So what do I need here? Well, you need to find the process which has the smallest start time, which has started the earliest, right? So that is difficult to do in a map, especially when I have initialized it as a hash map, because a hash map has no ordering. Now, some of you might be thinking that I need a map with ordering, like a sorted map in C++, and in Java you have a tree map. So when you have a tree map, what's going to end up happening is you are going to have login operations for everything, which is you want to make an update or search basically is login, and also deletion, updation, all those things are login. So we can think of a tree map. Okay, and let's say you go ahead with this thing over here, and you tell the tree map that, okay, processes dot remove this process ID if it has end time. So if this process ID has an end time, then you need to remove it. Now, which process ID? The very smallest one, like the first one. So it has a method for that. First entry dot get value dot get end time. If this is not equal to -1, so this is basically a null value, then you print this statement. So they have given you the format, process ID, and so on and so forth. So I'll just do that. This is the value that you have. So interestingly, how is this map going to be implemented? Like all of us know that order 1 is the time required for a hash map to store stuff and remove stuff and delete stuff and all that. But this map is actually giving you some sort of ordering also, and it's a map. So a lot of people assume that it's going to be order 1. That's not the case. It gives you login time, updates, deletions, searches, everything. So basically there's a AVL tree, or a red black tree inside this tree map. Yeah. So the red black tree has login operations speed, and when you say if the end time is -1 is not equal to -1, then you just go ahead and print. So process dot, let's set some other getter methods. Okay, get ID plus process dot get start time, and finally the end time also will be printed out. Okay, also interestingly, you might be seeing that this is taking a lot of time and stuff. In an interview you can tell it even more. It's even more clear that every line that you're writing seems to be taking too much time. So if you can, like in Google, it's not possible because they give you a Google Doc in which to write. So formatting is hard. But if you have any other ID that has been told to you, maybe HackerRank's ID or something, have a look whether you can format the lines easily. Because although the interviewer will say that they don't care about formatting, they do. They're human beings. They are going to like clean code a lot more, and clean has a lot to do with presentation instead of just structuring of the code also. So processes.remove, you're going to be removing this process. Okay, and this seems easy. Once you have removed the process, you're done, right? Okay, I'll just be taking doubts from you guys for the next 2 minutes. This solution is wrong, by the way. It's not going to work for various reasons, but let's see what kind of doubts you guys have. Oh yeah, before the live chat started, Yuvraj was someone who asked whether this is useful for freshers. Now that I'm coding it, I know it's not. It's really, it is actually, this bit is algorithmic. So it is very useful for freshers. But later on what will happen is that we look into the design of this code very deeply. In that case, it won't be useful. Till now, and also for the next 10-15 minutes, this is going to be very useful for your very first job interview also. Because I have not done any rocket science. I've just used a TreeMap, for God's sake. Okay. Okay, Sovan Ghosh says, I think we can use a heap here. Yes, that is true. You can. But that also won't work alone. And we'll see why. Okay, if you use a heap, first of all, just a heap, let's say. The problem is, how do you get this process ID quickly? That's going to be an order n operation in a heap. You can't search in a heap efficiently. You can only pull out the maximum. Okay, so your poll function will be really fast, order 1. Your start function will be fast, again, order log n, because a heap actually heapifies itself if required. And your end operation is going to be very slow. So that's the game we have here. We have 3 operations, and you want all of them to be less than log n. Right, and so you can't use a heap. You can't use a lot of the data structures we have been thinking about. We can't use a simple hash map. We have seen that. We can't use a simple list. So a hash map, the problem is the poll becomes slow. A list, the problem is the end method becomes slow. A heap has the same problem. What can we do? Okay, all right, sorted map. Yeah, that's what we're using. What we need to do in our case is to use a complicated data structure, in the sense that you can't have a single data structure which is going to do your job. Okay, so we are seeing that there's good stuff here in a map. When you say start and end, it's order 1 for a map. But the poll becomes really slow, order n. So can we take some of the good stuff from a map and some of the good stuff from a tree map, merge them together, and reduce the overall time complexity of all 3 functions? Yeah, Saurabh Kumar has a really good insight. Of course, this tree map is not sorted on anything. So the process method, like the process class, is not comparable. You can't compare 2 processes till you have defined how is the tree map going to store these processes, right? Oh, in fact, it has a string. So it's going to be sorted on this process IDs, not on the start times. And that is not what we want. So first entry is going to give you the smallest process ID, which is not necessarily the oldest process. As we saw here, 3 is the oldest, 1 is the youngest. Okay, that is a good catch, and we'll get to that also. But firstly, what we need to do is we can't actually use any of these data structures alone. A tree map has the issue that you can't sort on start times and get good end and start functions, right? If I sort this function, in fact, I'll do that in front of you so that it makes sense. So this is saying comparator of string. So I don't want that because I want it sorted on the start times. So instead, I need to actually store the process IDs. Instead of the process IDs, I need to store the start times. I don't know why I sound so confused, but in the real interview, actually, I didn't make any mistakes and I cleared it. Yeah. Okay. Okay, yeah, of course, the process ID is not what I want here, so I can't have that. I need another data structure, which is going to be a map. And this is going to be processes, while I'll change this to a queue, because that is what it is. I can pull from this queue and I can add to this queue, right? Based on the start times. So my tree map is no longer the set of processes I have. It is a queue in which one by one processes will be removed. How is this going to be initialized? Well, I'm going to be saying that take the start times of both these processes. So that is start time 1 and start time 2. And all I need to do is say that you need to compare the two start times, and then you're good. Okay. What is the problem here? Oh, of course, I haven't actually set this at the queue. Yeah. So now the tree map is correctly, initialized. I need the processes to be also initialized. So this dot processes is new hash map. Perfect. Shubhang Agarwal actually has the right answer. He's saying use a heap plus map. In my case, I'm using a tree map plus map because that logically, that's the conclusion we come to. But a heap plus map is enough. Because like you can see, it's a queue, right? So priority queue in Java is implemented using a heap. You can also use that over here. I'm just using this because it's a little more convenient. So the start method says that you have processes, you push this ID, and then you say that, this is what you have over here. So this doesn't change. What is the problem here? You need the required type as long. Oh, okay. I messed it up. Yeah, this is actually the processes. Yes. What is wrong in this? Oh, this is string. Oh, thank God. Okay. So the start now needs to also notify the queue that there is a new entry. So I'll just add that. System.current time millis. These two have to be the same. So I'll say the time now is this in both these cases. And the queue, I need to actually insert this now, comma, this process over here. Okay. Now again, going to the end method, all you need to do is you need to actually tell the queue that there's a end time in this process now. So interestingly, if you don't do this, if you don't tell the queue that there's a new end time, then the old start time remains, right? But the queue has not been updated. So every time you try to poll from the queue, you're going to be seeing that the queue does not have an end time. The task in the queue, the process in the queue does not have an end time. Okay. Now what can we do about this? I'll float the question in the chat. Guys, when I'm starting a process, when I'm getting the event of a start, I'm actually publishing that to the map and to the queue. But when the process is ending, I'm publishing that to the map. Do I need to publish that to the queue? Food for thought. We'll just wait for a minute till we get an answer. The question is simple. Do I need this line of code? does the queue need to know that there has been an update in the process? Okay, two answers till now, yes and no. Okay, most people are, oh wow, there's a 50% of yes and no going on. Okay, so let's try not to publish it and see what happens. Okay, poll says that I need to go to the queue, take the very first entry. This is sorted on the smallest timestamp. I get the value. If the end time is set, then I need to print this and remove it from the queue. All right. So I need to actually remove it from here, from processes, and I also remove it from the queue. So queue dot poll first entry will do the job. Okay. And if it is not set, then all I need to do is I just need to hold these processes in memory. Okay, and let's try to see how this works. So in fact, what I'll do is I'll just create a new class, or I can test it here itself, because you're unlikely to get a testing class in this. Okay, this is weird. I forgot to add class. Wow, look at that. Huh, much better. Is declared already. Okay, that's okay. Sometimes I really think whether I know how to code in Java or not. Okay. So, and what we need is we need a logger. So LogClient implementation is over here, and we have logger. Okay, so now what I'll be doing is I'll be sending some, what do they say? Processes in this. Yeah, they're calling it processes. In some cases, they're called tasks too. So that's another interesting thing. But yeah, I'll send process ID 1, then I'll send process ID 3, then I send process ID 2. But before that, process ID 1 has ended. And then process ID 2 also ends. And finally, process ID 3 ends. Okay, and is this according to the order that we have? I'll just copy this stuff. In fact, it's not. So 3 has to start first. But yeah, in our case, what should happen at the end of it is 1 should be printed out first. Then 2 should be printed out. Yeah, 3 should be printed out next. And then 2 should be printed out. Okay, and what I'm going to do is I'm going to be actually trying to poll the logger every time. Okay, so okay, and finally I'll just pull the logger again. So this is a very poor way of testing, but this is just to also clarify, what goes on. And in fact, in the poll method, if there is nothing, then I will be printing out else no completed tasks in queue. Okay. Okay. Now let's run this. Varun Jain has a good, he's made a good observation. We need them to wait. So that will happen soon enough, but this is just to make sure that things are working fine. Oh god, okay. There's a null pointer exception in some other class. Okay. That is not what I want. I want the implementation over here. Oh, okay. So while practicing for this, like you can tell how original this interview is, just to make sure that I don't mess up in this live stream. I have already coded this class out earlier. So by mistake, I actually set that as the implementation. Okay, Shubham Agarwal has a question. Can we use a mutex in poll method to not waste COGS? I don't know what COGS is, and only release that mutex once the youngest process is complete. Okay. Well, a mutex, like what are you going to take the lock on? The whole class? If you take a lock on the whole class, it's as good as a single threaded thing. So that is going to be a little bit of a problem, but you can tell your interviewer that if you want all guarantees that you can have during concurrency, then yeah, go for a single threaded or a global lock, basically. On the other hand, if you want to order it causally, we'll see how we can do that. I don't really know. 15 minutes are remaining. So this could be like part one of this, because the first 15 minutes we lost. But yeah, what's the problem here? Okay, we have a null pointer exception now. That is better. But process 1 started and ended at 0. Oh, okay. And we can see that the problem of not actually updating the queue is clear here. Okay. And then process 3 started and ended. That is good. But then you end up having a null pointer exception at line number 110, which is over here. Oh, okay. In fact, it's not even waiting. It's not even waiting for the class to be ready. So I have made a mistake here. I haven't actually told them that the end time has to be initialized to -1. So that's a bug. Let's just run this again. Brijesh Gupta is asking, we need to remove the process which ends first, not the one which starts first. Correct me if I'm wrong. Well, you need to actually remove the process which starts first. So effectively what you're doing is multiple processes and their events are being sent to you. You are ordering them according to the start times, and you're printing them only when they are completed. So if a process has started 10 hours ago and another process has started 1 hour ago, and the 1 hour ago process has ended, it's a short process, you're still not going to print it in your log because you're waiting for the first process, the previous process, to end. So the printing is going sequentially and is waiting for each process to complete, while the other processes are in queue, in line. They'll be held in memory till the previous ones are printed out, and then their turn will come in the poll. Okay, so over here we are seeing that there is no tasks had ended in the first 2 polls, which makes sense. Then we ended task 1, that is correct. Then 2 other polls, nothing had ended. There was the next 2 polls, like, okay, 3, yeah, this is line number 3. Line number 4 is nothing had ended. 2, okay, no completed tasks in queue for end of 2, because 3 has not completed. 3 started before 2, and that's the reason why, despite a process being ready to be printed, we didn't print it because this was inline. So I'll just actually no completed tasks in queue, and I'll also tell you the queue dot first entry. Okay, and dot get value dot get id. So now this is going to tell you the first entry in the queue, and that will be clear. What if this is null? Oh yeah, what if this is null? So in fact, I can just print out the queue size, and that will be good enough. Okay, now a lot of, I had asked this question that in the end event, do I need to update the queue? And the reason I didn't do that is because the update is happening on the object. The queue has a reference to that object, which also is, the map also has a reference to the same object. So it is updating it, and the queue is automatically getting updated. Okay, so we don't need to change that. Okay, and finally, like, what are the number of tasks in the queue? Initially there is 1, then there is 2, then this task ended, so you kicked it out of the queue over here. So when this process ended, you should have kicked it out of the queue, and the number of tasks should have been 1. That is weird. Okay, and after that, of course, you added a task. So I'll just say start. Yeah, so the start has happened, and you have put in 2, but none of the tasks are ready. Then you ended 2. The queue did not evict it. It said that no completed tasks in queue. And then finally, when you are done with 3, you kick that out, and then again you kick this out, and now finally the size should be 0. So let's see if that happens. Okay, Shubham Agarwal again. If we take a lock mutex in poll method, the thread calling the poll method will not waste CPU cycles checking the top of the heap tree map. It will be notified once the youngest process is done. Okay, if you take a lock or a mutex in the poll method, okay, I'm just going to think about a synchronized thing. The thread calling the poll method will not waste CPU cycles. Yes, that is interesting, but you have to take into consideration that if there is serious concurrency, someone might be updating this, someone might be updating this, and the poll method is also updating the same data structures. So there is a possibility that concurrency might screw this solution completely, and in fact it will. In the current implementation, of course, it's not going to be a problem, but later on you'll see that if concurrency is allowed, that's a real problem. Okay, another null pointer exception. How very interesting. But you're seeing that 2 has also been evicted from the queue. Oh, okay. We need to actually check if there are any entries in the queue. So if otherwise we'll have a null pointer exception. Queue is empty. Okay, so this will work, of course. I'll just make it a little clearer. Okay, queue is empty, and then it threw a null pointer exception. Why would it do that? Oh, I didn't return, of course. So this is fine. We don't need to go through this bit. But okay, so guys, this is a very, this solution has actually not touched on the key points of this problem. Okay, the key point of this problem, by the way, what happened is once this solution was presented, you need to think about 2 things in any LLD question, and hopefully in the next one I'll be able to do it more, in a structured process. But firstly, you think about what is the solution to your problem. Okay, in some cases, like over here, there's an algorithmic solution. It's not straightforward. You don't just go ahead and talk about the classes and the objects and the state. No, you're going to be actually designing a solution which will have order log n time for all three processes: start, end, and poll. So that is going to take you some time. You are going to do that on a pen and a paper. Once you're sure of that, you go ahead with the code. But even when you're coding, you need to be aware that the interviewer is expecting you to talk about concurrency eventually. Okay, and they're going to be expecting you to talk about how do we test this class. So in part 2, I will be talking about concurrency, which is the most important thing in this low-level design question actually. Or I would say like it's maybe 60% has been taken care of, honestly, by just solving the algorithmic problem. You have done your job. But now, what about concurrency, and what about the test cases that you can throw at this problem? Okay, and if you have like a low-level design question, they're probably not going to be asking you both together unless it's a 2-hour interview. They're going to be focusing either A, on your test cases and your ability to handle concurrency, or B, they're going to be testing you on your algorithms. So, but whatever be the case, you need to be able to at least mention the kind of problems that your solution has, algorithmically or engineering wise. Okay, that is the gist of this. I'll take this as part 1 because we are just out of time. But guys, if you have any questions for the next 3 minutes, I'll be taking questions, and let me know, if you have any doubts on this, on what we have built currently. Okay, Amrit M is asking, do you really get to code in a LLD, or is it just writing on the paper the objects and relationships? You do get to code. So initially you have either paper or you have a board where you draw and you give a high level understanding of how you'll be solving the problem. But I think LLD interviews are one of the toughest interviews out there, mainly because it's very objective. If you look at it, like it brings a lot of objectivity to such a subjective design question, where your code is expected to compile and one happy path is expected of you. Like, because you're writing test cases, right? If you are given 2 hours in your interview, in some cases machine coding rounds, like there's 2 hours, so they expect you to have working code at the end of it. You need to design and have a little bit of working code. And of course, it's very similar to a high level design / algorithm interview where you are solving a problem and you're trying to find a solution and code it. But over here, your design also has to be good. So this is much more of a mixture of all three than anything else. Like a low-level design question for me is a mixture of algorithms, engineering, and HLD. So that's the reason why I find this to be the hardest. And that's the reason why in my course right now, it's taking so much time to come up with good solutions to LLD problems. Yeah, and explaining them, it takes a lot of time. It takes a lot of the code itself takes so much time, and then you have to edit out things and then explain them on paper. But of course, that has to be done. But hopefully I'll have a set of videos out which are going to be explaining this so much better. The live session is to just give you a glimpse of what happens in a real interview when you're asked to code things live. So yeah, that's the idea. Zia Khan is asking, where was this asked? Google. Yes, that is where it was asked. I mean, in a Google interview rather. Okay, Anupam is asking, please iterate the complexities now of these three methods. The start time has a complexity of log n because the queue is, you're putting something in the queue. This is a tree map. A tree map has a complexity of log n because the comparator over here, it's not hashing, it's actually a comparison operation. So there's going to be a binary search over here in the map. It's a BST for all purposes. The end method has a time of order 1 because you're not updating the queue, you're just updating the reference in the hash map. And the poll method has a time complexity of log n because the queue, you're evicting the entry from the queue over here. and you're removing from processes, that is order 1. So this is the total time complexity. Log n, order 1, log n. So when Ghosh is asking for the code to be put on GitHub, yes, that is going to happen. Guys, if I can be honest, like this part of the interview is what a fresher needs to know about. Like this is the bare minimum that is expected of everyone, that you are able to solve a small algorithmic problem. After this, like in part 2, it's focused on SD2s, SD3s, okay, where you're expected to have a good concurrency managing class. Okay, so we'll get to that next time. And thank you all for tuning in. Apologies for the first 15 minutes. We had some technical issues. I'll make sure that it doesn't happen again. Or if it does happen, then I'll make sure that we are well set for that. Thank you for having a look at this code. I'll be posting everything in GitHub. See you then. Bye-bye.